Hello guys. Well, we just finished mechanical waves and now we're moving on to the second type of waves, which are electromagnetic waves. Now, they are produced by particles moving back and forth, and the important thing is that they do not require a medium. That's super important. Okay? Just like before in our mechanical waves, the amount of energy is determined by the frequency. The higher the frequency, the more energy there is. So those waves that are really close together, wavelengths that are really close together have more energy than those that are spread out. Electromagnetic waves travel at the speed of light, which is 300,000 kilometers per second in space. That's so it doesn't bump into any molecules of air. It's a little bit slower, not much, when it's down here in our atmosphere where there is air. Okay, so electromagnetic waves have different frequencies. Now, here is a chart, and you're going to get familiar with this chart. The chart I'm going to be giving you is a little simpler than this, but here are the wavelengths listed across the top, and here are the frequencies. Now remember, we did scientific notation already, so these little superscripts are going to tell us how many more zeros to add to that. So these are really high numbers. Okay, here's this easier graph, and this one's flipped on, no it's not, this one's the same. So we start with radio waves. They have the least amount of energy, and as we travel across the electromagnetic spectrum, we're going to get to the most energetic waves, which are gamma waves. Okay, so radio waves were at the far end of our spectrum. They have the lowest frequency and carry the least amount of energy. They are made by vibrating electrons up and down in a piece of metal called an antenna. And some of the radio wavelengths can be longer than a football field. Now, you guys are pretty familiar with radio waves. Most of you carry around a device in your pockets all day long that use radio waves, and that is your cell phone. Your cell phone actually has an antenna in it, and it sends radio waves back and forth to the nearest cell tower. Here is an example of a transmitter, and this is an old-fashioned radio. Okay, so radios in your car use radio. Extremely low frequency, these are sounds that we can't hear. They use to communicate with submarines. Old school TV, if you have a TV that has rabbit ears, that uses old school, or that uses radio. Satellite TVs, if you have a satellite dish mounted onto your house or in your yard that faces south, it's communicating with the satellite that's stuck in an orbit right above the equator, and it's sending radio waves to your house, and that dish is collecting the radio waves. Your cell phones that I've already mentioned. Walkie-talkies, if you have a set of walkie-talkies, those use radio waves. And if you have a remote-controlled car or truck or boat, those are actually radio controlled. That's what RC stands for, not remote controlled. Okay, the next type of electromagnetic radiation that's a little more energetic are microwaves, just like what you have in your kitchen. Okay, these wavelengths can be measured in centimeters, much smaller than radio waves. And the the microwaves that heat our food are around 30 centimeters. That's the length of a ruler. So those waves are the ones that heat your food. The microwaves cause the food to vibrate, and as they vibrate, they cause friction, which causes heat, which heats up your food. Microwaves are also used for transmitting information. There's microwaves in our atmosphere because microwaves do better than radio waves at getting through bad weather, smoke, and haze. And then here's a quick little video that I'm going to attach later on about putting metal in the microwave. The next electromagnetic waves are infrared waves. These are waves that give off heat. Some animals, such as pit viper snakes, can sense infrared. They can see the heat. And I'll attach this video as well. The next type of electromagnetic radiation is visible light. And visible light is the only type of electromagnetic radiation that humans can see. That's why it's called visible. It's visible to us. And the molecules begin vibrating so fast now that our eyes can detect them. The other types of electromagnetic radiation, the waves were much slower and they weren't causing things to shift. Okay, the visible light spectrum is Roy G. Biv. You guys are going to learn that. And Roy G. Biv stands for red, orange, yellow, green, blue, indigo, and violet. And that is the colors of the rainbow. When you split white light, and we'll spend more time on this, when you split white light, it makes the colors of the rainbow. Here's an example of them as well. The highest energy is down here in the violet. The lowest energy is up in the red. Okay. Once you get past visible light, we're going into ultraviolet radiation. This is above what we can see, and it's above violet, so higher frequencies than visible light. This radiation can be harmful to animals like us. This is what gives us a sunburn. It's not the visible light. It's not how much sun is out there, how sunny the day is. It's actually what we can't see, which is UV radiation. When you wear sun protection, it'll say it's against UVA and UVB, and it has a sun protection factor, that's what SPF stands for, of 25 or 50. I have relatives that have to wear 100 SPF. Okay, fortunately for us, ozone, which is in the atmosphere, blocks most of this radiation, so we don't get a sunburn every time we go outside. The benefits of ultraviolet radiation is that they produce vitamin D, which is essential for healthy bodies, and it's used as a disinfectant. Right now we are in an era where we are disinfecting lots and lots of things to prevent us from contracting COVID, and UV radiation is one of those. They can shine this form of radiation on instruments and it will disinfect them. Your dentist office often uses this to clean the tools. Then we're getting to really high frequency. Next we have X-rays. Now, if any of you have ever broken a bone, you've probably had an X-ray, okay? X-rays are so energetic that they can go through skin and muscles. An X-ray film shows the shadow. So here's an X-ray film, and the shadow are the bones where this radiation is being blocked. Just like the sun can be blocked by a house and cast a shadow, X-rays are blocked by bone, but you can see where they penetrate through the skin and the muscles. Okay, here's another form of an X-ray. And then the very end, the most energetic form is called gamma radiation. Okay, gamma have the smallest wavelengths and the most energy in the electromagnetic spectrum. Okay, they can pass through nearly all objects, and they're also used to treat certain type of cancers. If you ever hear someone mention that they know someone going through radiation treatment, what they're actually doing is shooting gamma rays at their tumors to help destroy them. And this is, I had radiation treatment years ago. I had a type of cancer called leukemia, and I had to go down into the basement of this hospital, and it's not this exact one, but very similar, and they have these two machines. Can you see the nuclear symbol on the side? That would give off gamma radiation in an attempt to kill the cancer cells in my body. All right, that's an overview of the electromagnetic spectrum.